you people will be familiar with. I'll show you some pictures of some of them later. My robots tend to be very large, mostly underground and invisible. But of course, they're important because our country, my country, Australia, which is the largest, which China is our largest trading partner, because you buy all the minerals from us. And those are dug up from the ground by machines that I do. But my talk is a little bit more general on that. I want to extrapolate from the work that I am doing into automation and how it affects the future of all of us. It's a very important subject because work defines us as people and has done for thousands, well, for as long as the human race is in existence. Work has both a cultural, a philosophical, and economic effect on us all. Our very sense of well-being revolves around our ability to contribute to the society around us. If people cannot contribute to the society around us, that has physiological ill effects. And I'm going to talk to you about what's happening in the world in terms of automation as I see it. Break it up into physiological and mental components and give a projection. And it's very important because what happens in the future is going to be determined by policies, politics, decisions that we make now. So this is food for thought, this discussion on automation. Because, and nowhere is it more important than a country like China. You have a huge population. You have a vastly growing resource needs. And things are happening in the world, in AI, in computer science, in robotics, that are going to affect us all. Ironically, although China is probably in the most, the firing line for some of the automation technologies and how it will affect the general population, they're also possibly in a politically better position than many to actually react to the changes that are coming down the pipeline. But to start the talk off, I want to go back in history and to have a look at just a couple of photos that I'd like to show people, giving examples of work, just one or two, that took place a few thousand years ago. This one's actually only a few hundred years ago, and it shows, as you can see, a combine harvester. Two people supervising on the oxen, the other supervising the front end of it, where they're threshing wheat into the catchment of the machine. We can look at that, we can understand that. If you went back 400 years, that would not look odd. Remember, 400 years ago, for every person in the town, there were 70 people in the fields. We have now come to an interesting reversal. Now, for every person in the field, we have 70 people in the town. But still, that work does not look strange to us. I will show you similarities to what I'm doing later. Here's an earlier piece, about 2,000-year-old fresco, currently at the Augmentation Museum, showing a Roman woman looking at a laptop computer. This person here is probably a house slave, judging by the amulet around their neck. If you have a look at, normally slaves did not wear togas, but house slaves basically wore what the Mr. or Master of the house actually said. And this is a situation, 2,000 years ago, everyone can understand what's happening. The person on the right who's got some degree of authority is supervising the person on the left who is doing some degree of work for that person. And that relationship is fairly straightforward. We can again understand what's going on there. What I'm about to explain to you is that the changes that are going to happen to work are such that we will not comprehend what is going on. We will not recognize work that takes place in the future. Let's move on and have a look at what we are as human. I'm going to discuss now the basis of this premise, which comes down to what we are physiologically endowed with as human. And I like to do this with a device, which I call a human capabilities matrix. And the human capabilities matrix is combined with thousands and thousands of little graphs like this, which we combine to form a kind of isosurface which describes a human thing. This one is simply showing a person's work output based on the temperature that they're working in. You can see as the temperature goes too low, people die, so they can't work anymore. If the temperature goes too high, people similarly can't work because we can't achieve homeostasis. We cannot cool down. Our bodies cannot get rid of the excess heat that is being generated by our organism. And this curve is common for many other physiological processes. Our ability to withstand physiological pressures, the pressure that we can operate in, the atmosphere that we can operate in. If we take all of these different characteristics of human beings, put them together into an isosurface, we get some kind of multi-dimensional shape. And this is purely representative of it, but that basically represents in an isosurface what people can do. And that is what they can do with their normal physiological endowment. That is, with the normal genetic expression that has made us what we are. And that hasn't changed for thousands, millions, probably 500,000 years. We've been much the same as what we are now. When we come to do some work, we have a job space which has certain requirements. And those requirements will be the temperature that you have to operate in. There'll be the pressures that you're working on, the noise, the ambient noise, the sensors that you are required to use. And all of those things, when you combine with the human being, you get something like this. You get an overlap, a disparity between what a person's natural endowment can do and what the job requires us to do. That's pretty straightforward. In my world, of course, which is mining, it's a pretty rough environment. That disparity is quite high. The environment is dangerous. There's noise and smoke and fumes. There's ever-present danger of rockfalls. And so we augment a person's ability by using personal protective equipment like helmets, breathing apparatus if necessary. You see that on the people on the right. But most of all, of course, we augment it by using machines. Like there's just a straight shot breathing machine, straight concrete. One of my robots over there working in the mine. We use it to augment the human's natural ability and to allow them to operate safely in that environment. If we go back to our matrix, we have our before augmentation, and then by adding things to us after augmentation, that our capabilities matrix now extends to be able to cover the job space that we're going to achieve. Straightforward. A fairly simple concept. And we do this all the time. Some jobs require more augmentation, some jobs require less augmentation. We augment ourselves all the time with our clothing, with things like this iPad. This iPad probably adds, say, 10 IQ points to me as I'm doing things. I can now get in touch with any information in the world through my iPad, which has given us enormous power that was just not possible 50, 100 years ago. Let's move on to what working robots are like, and let's compare it to what we've been talking about before historically. This is one of my robots. The lighting's not that good, but you can see it's that one's about a 45-ton front-end loader, fully automated. Once upon a time, those machines had people on them, but in my country, they were killing 4 people per year on those machines. So we automated those machines so that now there's nobody on those machines. The machines work 24 hours a day, 7 days a week, and you may have one person on the surface supervising 4 or 5 or 6 of those machines. So it's very much like if we go back to the lady sitting in the chair, we now have humans supervising those machines. And a lot of automation is about this transition of supervision. We start off with ourselves doing the work, we build better tools, our tools become semi-autonomous, and then we increasingly step back and supervise them from afar. And if you look at that, you can see a remarkable similarity between this 500-year-old threshing machine and the loaders that we use now. And that's because they've come out of the same world. People said, okay, we want to scoop up rocks, so we do things like that. But of course, modern automation does not have to be like that. Modern automation looks more like this. And I defy people in this room without an engineering background to tell me what most of those machines are actually doing. Those machines are cooperative. Parts are handed backwards and forwards between the machines. Each machine is multi-skilled. And the whole series of machines that are there are supervised by one person over there. And that's all that is required to supervise that entire plant, which is actually making Tesla automobiles in the US. This trend towards automation is not just unique to the mining industry or the car industry. Let's look at the US and the manufacturing industry. That is the current US Bureau of Statistics trend for employment as a percentage of the workforce on the slide and the manufacturing output as a percentage of GDP. You can see that as a percentage of GDP hasn't changed. But the number of people, or percentage of the US workforce, is declining at a fairly steady rate. And if we want to extend that, then we can. There you can see that by the year 2030, by that graph, no one will be employed in manufacturing in the United States of America. No, not a soul. But the GDP output will remain the same. And what we're seeing there is this collapse in one person supervising more and more people, until ultimately it ends up as the owners of the companies basically letting the machines run themselves. And you're seeing that in China as well. You've probably all read that Foxconn, who are making Apple products in the south of China, are now replacing some of their workers with over 2 million robots. There's good reason for that, because when we take an iPad off an assembly line like this, the iPads originally had about a 40 to 50% chance of failure, simply because of dust particles, other elements that get into the manufacture, of course, pixels to die on the screen. Robots don't have that problem because, as we discussed in our capabilities matrix, the robots can work in areas that we cannot. They have a much broader ability, a much greater environmental range of dexterity. If we look at some of those fundamentals quickly, you can see dexterity, obvious, agility, the ability to manipulate small objects at varying scales. We've got the environmental constraints. We've got the sensory capabilities. And scalability, meaning cooperative behavior. And of course, another important one is the mental capacity. What I want to do now is, before I talk about where we are with all of those, I want to talk about some of those and give you some examples of, say, some of those characteristics being done by robot people. You may have seen these. Here's a nice slow motion clip of a little robot juggling a ping pong ball. A lot of these clips you can find on YouTube. Pretty good. Watch at the end here, he misses it once. And he has a go for it. I want you to just think how nearly human that is. See him having a go? Missed it. Gives up. All right. Okay, that's pretty effective. Let's look at it in real time. Let's look at that again in real time. All right. That's the sort of dexterity that humans cannot do. They cannot do that. That's not only Dexterity in terms of movement of the arms, there's also associated the ability to track that ball in time and space in order to do that. Humans cannot do that. Machines can. Let's have a look, another dexterity. In this case, you probably didn't see what that did. It tied a knot in mid-air. It threw a cord up into the air, pushed it through, and tied a knot in a piece of string with one hand. I'll play that again, if I can, because that's the way no, I can't play it. Let's move on to the next. Here's another example. This one, in this case, I'm showing the agility of the machine. That's a little flying helicopter, balancing a pole on the helicopter. Right? That's not good enough. We want to throw the pole on another helicopter. And there you have an example of agility again that humans find very difficult. Watch this again. And this is showing a sort of cooperative behavior that is possible between robotic systems. Because unlike us that has to talk at a fairly low bandwidth, these things can communicate at effectively the speed of light. Radio communication plus data. And here are just some basic maths of how they do it. There's nothing complicated in the maths in this. It's just implementing in real time that is where machines get the edge. And you watch how accurate this thing achieves theory with practice. Let's move on to another one. Also using little quadricopters, which is something we're looking at the moment. This is again showing cooperative behaviour between various, between little groups of quadricopters. In this case, they're throwing balls, etc., through hoops. Right? Catch the ball and throw the ball. Catch, throw. Pretty easy.
So you could save people from a burning building.
That's it. They could save people from a burning building. The hospitals around us. We're looking at quadricopters for mine rescue, so that they can go and find people that may have been hurt, and thus we can better redirect resources, etc. And here they are again, just showing that they can throw the thing from side to side, and eventually they can actually throw them through objects. And of course, like everything, the systems are self-learning. Missed? No problem. I think about it, try again, missed again, let's try about the third time. There we go. So cooperative behaviours. So basically, what we're saying is that the robots, automation systems, are actually getting pretty good at most of the things that you see on that group. In fact, all of the things on that group, except the one in the lower right-hand corner. And that one, as you know, mental, is pretty much where humans now dominate. That is our forte. Now, computers, of course, and automation, in the past, has always been targeting things we are bad at. There's no point in automating something we're good at. There's no economic value in doing it. In fact, the very name computer was once a job title for a person who used to work out mathematical ephemeris tables, which they used in navigation, working out the sunrise and sunset. And that was that person's job. That person was called a computer. He used to wear it on his name tag. A computer back in the 17th century. And of course, when computers came along, that was the first job that went, because it was boring. People make mistakes. Computers do not. If they do what supercomputers, where are they in terms of the mental sphere? Now, of course, we have experts in this room on this, Ben, etc. This is their domain. This is what they're working. Let's just look at one set of computers, which is the supercomputers, and for those who are Chinese, you may be aware that the current world champion in supercomputers is Chinese. It took over from one from the US in the last few months. So China currently holds the crown. And this red line here indicates the current rise on an exponential graph of supercomputing usage, which generally is ahead of your desktop computers by between 10 and 15 years. That computing power, as you can see, we're now around 50 odd petaflops, new Chinese supercomputer, around 50 odd petaflops. That's enormous. One petaflop, 10 to 15, is enormous amount of computing power. If you do an assessment of the human brain, how much possible computing power do we have in the human brain? The answer is somewhere between 10 to 1 exaflop. The consequences are that our hardware is now getting close to us. That's our hardware. Our software may be lagging by many years, but the hardware is nearly there. On one computer. It may be the size of a warehouse, but we're getting there. And remember, computers, unlike us, can be networked much more than we can. It takes signals in my neurons can travel at a maximum of about 100 meters per second. The time it takes to get a signal from one half of my brain to the other half of my brain, I can send a signal from here to Hong Kong and back. I can send data from here across the outside of the country and back again. In the same time it takes to get data from one side of my head to the other. And there is a lot of computing power, as in machine computing power, between here and Hong Kong. So whilst we may augment ourselves using devices like this, we still have a fundamental limitation on our mental capacity, which computers can outperform if they can ever run the same software as us. I'm not saying they can, but the indications they are, and the Church-Turing hypothesis would imply that they can. Let's have another look, a fairly significant graph, and that is the cost per computing power, because this is the type of chart that economics is based upon. How much does it cost per gigaflop to do those calculations, to do those sums? And as you can see, that cost has been plummeting. And most importantly, it is now crossing the cost of kids. If you take into account the number of neurons in the human brain, the amount of time it takes to train a human being from 0 up to when they leave university, we're talking about $500,000. The cost of computing power is actually now, in the last few years, just starting to dip below that number. So what we're saying is computers are now cheaper than people. We don't have the software that computers can be placed in those supervisory roles at this time. But the evidence is there that we will get it. That's exactly what some people in this room are working on. The consequence of all of this, what does the summary of this mean? If you take into account the fact that robots already have the dexterity, the agility, the ability to perform cooperatively that we have, and that they will at some point in the future get the same mental faculties as us, the inescapable conclusion you must face is that there is no future for human life. And that is a problem. I'm not offering a solution, but I'm saying there's something we all need to be thinking about now, so that we can discuss it, we can get people to understand it, be aware of it, we can talk to people who are influential, and we can make plans. When the Industrial Revolution took place in the 1700s, late 1700s, initially there was massive transformation. People were unemployed, thrown off the land. People went into jobs like coal mining because they turned from wood and peat into coal. Massive air pollution, much worse than you would have in Beijing at the moment. And it wasn't nice for a lot of people. Certainly, the benefits did come later. Diet improved. The average health and life expectancy of everyone was ultimately benefited by the Industrial Revolution. We are now on the verge of the second phase of that Industrial Revolution. We are going to move beyond the machine to the mental sphere, and it is there that the next revolution will take place, and is taking place now. This is a very important subject. Talk about it amongst your friends. Be active, be aware, and let's see if we can't move every one of us into a happy future without the shock of going through it, which is suffering apart. And that's all I want to say. If you want to ask questions, lots of hydraulic drills in my ear, I don't hear very well, so I'm going to ask you to use a microphone.
Hi everyone, my name is Alina. I'm from 360 Fashion. That was amazing and eye-opening, and I have tons of notes, so I'm just going to read them all off to you, okay? So exactly what you said at the end. So what role will humans play when everything is automated? How will humans make money? Where will we be totally jobless? Will we move into a riot sort of situation where we are all sort of fighting because there's no economic, way to generate a living? How does the cost of robots versus the cost of humans, and I mean in a total cost sense, taking into consideration the future? And has anyone thought long-term about this? The whole iRobot and other movies warn us of how this can all terribly go wrong. If we think only about short-term profit, right? Today, using robots, yeah, I can perhaps make more cars and more money and more this. If we think only of that short-term profit, can we also choose not to go into the machine age paradigm?
I'll start backwards. I don't think we can stop going to a machine age paradigm because the world is not united. That one country can't really do it alone. They can say no, but then they will be surpassed by everyone else, and everyone will want the goodies that come from this future robot, whatever happens. I think if you look at how it will affect us socially, the obvious thing is what happens now when a person cannot compete in the workforce? And the answer is they are provided with some kind of disability pension, certainly in some Western countries. So I think you'll see more of that. What will happen is we will recognise that the average human being cannot compete in the workforce. And depending on the socio-economic system in place, then the government will try and distribute wealth to those people by taxing the remaining, the owners of the means of production that own this. And I'm sure Jack Strachey is going to talk about this more when he talks about the economics of what's happening. So I think the answer to that is that we will all be disabled. What will we do though? And I point out to that very first slide that I showed you. I go back. Maybe that's our future. We'll all sit around in happy togas and live a sort of virtual utopian existence. Maybe, unlikely. I tend to think that we have a lot of the problems that we have are going to be psychological as much as they are other things. Because if you look at any cases where an indigenous population has been supplanted by another population, like in my country, the Aboriginals were supplanted by the English culture as they came across. And what happened was that you had itinerant Irish labourers wandering the countryside, and they had all this to the Aboriginal
and goodies, things that people wanted. And so suddenly the males of those societies found themselves devalued. They were no longer able to provide for the family. They didn't know they were poor, but suddenly they discovered that they were poor compared to these newcomers. And that causes enormous psychological problems. And that is a real problem. I cannot offer a solution to that, but it's certainly going to be there. How do we exist in a future where the world we were designed for, which is not now, we were not designed for this world. We were designed for 500,000 years ago. We were designed for that hunter-gatherer environment that we came from. And our mental processes have been structured for that environment.
What do you think of Ray Kurzweil's solution, which is basically we become one with the machine, rather than being an either-or situation?
Yes, and that is...
Put this in here.
Yes, and that is a possibility, but my concern with that is that there's a lot of inherent inefficiencies in the biological processing, whereas the external processing is so much more efficient. Why would they bother? Why would you say, look, I've got this nice iPad here, let's put a really dumb, slow chip in it. They wouldn't do it. It doesn't make sense to do that. So I'm sorry, I can't answer your question because I don't know. But it is something we need to think about. Of course, as I say, the decisions we make now affect the future. We have to be aware of these things. And in some cases, it's going to be structural. I tend to think that ideological capitalism, like in the Western country, like in the US, is in a far worse position to deal with it than a semi-controlled economy such as China, who are in a better position to say, no, we won't do that, or keep those machines running. Build those things, we want those things. You don't create scarcity, etc. Anyway, again, I don't think approach on the following talk, we should be talking more about the economics. Professor Nicholas.
There are cultures in the
There's
past.
two microphones, by the way.
Hello.
You gotta turn that.
What's going on?
James, there are cultures on the planet that work about 2 hours. So you go for lunch, there's climate.
That's what they're government employees, right?
And they fill up the rest of their day with elaborate religious and artistic rituals. So for them, not having ritual work is not a problem. Human brain adapts to a workless environment. And it's been around for thousands of years.
We definitely have over here, sorry. If you go to Korea now, most of the youth sit in video game parlors, living in a virtual world, which surprisingly is sort of harkening back to the previous world we came from, not surprisingly. They're in danger, they're fighting each other, shooting each other, they live in a constant, and that's all they do for 12, 15 hours a day. Maybe that's the future. Solipsistic, unsatisfying to me, but maybe that's the future, that we will compensate for our lack of need by creating a virtual world and living in that. Quite possible. All right, I think we'll...
All right, yeah, so James has covered a lot of interesting ground here, from the near-term prospects of automation, all sorts of irritating work that most everyone would rather not do, to the long-range prospect, like once the robots do all the work, what's left for us to do? Do they just leave us in the dust like the Cro-Magnons did the Neanderthals, or are we kept alive in a people zoo maintained by the friendly robots? Do we fuse with robots like cyborgs, or is there some sort of peaceful coexistence between humans and engineered post-human life forms? I mean, it's hard to figure really rationally about things that many steps away from where we are now. But I think he's right that these are issues we should all be thinking about as we shape the future together. So next.